Hi students, this is AJ sir. Let's study 10th standard ICSE Math, Chapter 8, Remainder and Factor Theorems. Exercise 8A, question 1.1 is cancelled. Let's do question 1.3. Find the remainder when x to the power 4 plus 1 is divided by x plus 1. So you can see here, this is a polynomial. It is to be divided and we have to find the remainder. Now there is a long division method. This is how we divide polynomials. We'll get into this little later. But using the factor and remainder theorem, we can find the remainder even without actually performing the division. And that's what we'll do here. So the theorem says that if we have to divide it by, let's say, x plus 1, then assume the value to be x is equal to minus 1, substitute it in the expression, solve, whatever answer you get, that is the remainder. So since we have to divide it by x plus 1, we always assume it to be equal to 0, so that we can assume the value of x is equal to minus 1. If we had to divide it by, let's say, x minus 1, then what is the value of x which we shall assume? X is equal to 1. If we have to divide by x minus 2, then we'll assume the value of x is equal to 2, because minus 2 will shift and become plus 2. So the reason why we do this is because when we substitute the value of x as minus 1 in this polynomial, let's represent it as f of x, which is function of x. So instead of x, if I put minus 1, and then I solve, whatever answer I get, that is the remainder. So the remainder is 2. So clearly, this division proves that x plus 1 is not a factor of x raised to 4 plus 1, because if it were a perfect factor, the remainder would have been 0. Now question 2.2, show that this is a factor of this polynomial. Now how can we prove that something is a factor of the polynomial? One way would be to divide it by the long method and make sure that the remainder is 0. That way it proves that this is a factor, because if the remainder is not 0, that means it's not a factor of this. But again, we are going to use the remainder factor theorem. Without dividing, we will prove that it is indeed a factor of this. And how do we do that? We'll assume a value of x, we will substitute it in this polynomial, we will solve and check, are we getting 0 as the answer or not? If we get it as 0, then it is a factor. Since they have said show that means prove that, we should be sure that the answer will come as 0 when we substitute. They didn't say check if it is a factor or not. In that case, we are not sure. If it comes as 0, then it is a factor. If not, then we have to say it is not a factor. But here I'm sure it will be 0. So again, we have to divide it by 3x plus 2. So always assume it to be 0. Shift 2 becomes minus 2. Shift 3, it becomes upon 3. So what is the assumption we are making? X is equal to minus 2 upon 3. Notice how there was no negative sign, but now there is a negative sign in our assumption. Function of x is, this is the polynomial, this is the question in fact. Let's substitute the value of x as minus 2 upon 3. By doing that, x minus 2 upon 3, x minus 2 upon 3. Square, so minus sign goes away. Minus minus plus. LCM is required? Yes, it's required. Solve it. I got 0. So that means it is indeed a factor. If this was not 0, then it would not have been a factor. Next, cancel question 3. Let's do 4.2. Find the value of k if this is a factor of this expression. It's called an expression, not an equation, because there is no equal to sign here. So now they are saying that it is a factor. We don't have to prove it. But this k's value is unknown. x is a variable, yes, but k is also unknown. So we've got two unknown variables here. We have to find the value of k. If this is a factor of this, what does it mean? It means that if I substitute the value of x here and solve, I will get the remainder as 0. Remember, whenever remainder is 0, it means it's a factor. If something is a factor, that means remainder is 0. But what is the value of x we will substitute in this expression? Well, can you guess? By now you should be able to know. Well, I'll tell you, it is 4 upon 3. 4 upon 3, yes. Let's see how. So we always write 3x minus 4 is equal to 0. I want x alone, so minus 4 shifts becomes 4. 3 goes down. 4 upon 3 is what we will substitute the value of x as in this polynomial. Notice how there was a negative sign, but now we don't have a negative sign here. So the function of x is this. This is the question. We will substitute the value of x as 4 upon 3 everywhere, everywhere, everywhere. Now, we know that it is a factor. We know that the remainder will be 0. So I already know the value of function of 4 upon 3. It is 0 because it's a factor, right? So there is only one unknown variable here, k. So I solve this and get the value of k, which is 8. Next, the fifth sum. Find the values of constants a and b when this and that both are the factors of this expression. So in this expression I see two constants whose values are not yet found out, a and b. And we have two factors here. Great. That means each of these, when divided, will give me a remainder 0. So that is the rule we'll use to solve the sum. First I will substitute x as 2 and remainder is 0. Next I will substitute x as minus 3 and I'll get remainder as 0. I think I'll get two simultaneous equations in a and b, and then you know how to solve them simultaneously to get the values of a and b. So first of all, let's assume x as 2. Since it's a factor, when I substitute it in the expression, the remainder will be 0 because it's a factor. So I solve this and I get a simultaneous equation, first equation, a linear equation, Roman number 1. I've simplified it by dividing by 2, by the way. Similarly, the other factor was this, right? So let's assume the value of x as minus 3. So if I substitute this value in the expression, I should get the answer as the remainder as 0 because it's a factor. So again I solve it and I get the second linear equation. Again I simplified it by dividing by 3. So I got two equations. You can label it as Roman number 2 if you want to. I write them one below the other. I'm going to add them. B gets cancelled. A is left. Get the value of A. Substitute it in one of the equations. Get the value of B. And that's how the sum is done. Next, the seventh question. Find the value of A if x minus 2 is a factor of this. It's a simple sum. Same type. If this is a factor of this expression, that means when I substitute x as 2, I should get remainder as 0. And that's how we'll find the value of A. So if x is 2 and if I substitute x as 2 and I solve it, I should get remainder as 0. And so I solve and I get the value of A. Understand that only if they have mentioned that it is a factor can we write 0 in the very beginning. In sums where they have not mentioned that it is a factor, or they have asked us to check if it is a factor, don't write 0 in the beginning, because once you write 0 as a remainder, you are directly assuming that it is a factor, which is not correct. So be careful about this silly mistake which I see often. When do we write 0 as a remainder? Only if in the question it is clearly mentioned it is a factor. Next, let's do the ninth sum. When x cubed plus 2x squared minus kx plus 4 is divided by this, the remainder is k. Okay, that means first of all, this is not a factor. Secondly, they have not given the remainder in terms of number. They've given it as k. Find the value of the constant k. So constant or k is also there in the expression. Okay. So ninth sum. We have to divide it by x minus 2. So we'll assume x is equal to 2. We'll substitute the value of x as 2. But in this sum, will I say that the remainder is 0? No, it is not a factor. In fact, they have given the remainder as k. So let's write that. And I solve it further. I can see that in this equation, I have only one unknown variable, which is k. So I get the value of k. Are you okay? 11th sum. If this has x minus 2 as a factor, and it also leaves a remainder 3 when divided by this, so x minus 3 is not a factor because there the remainder is 3. Find the values of a and b. So they've given one factor and they've given another divisor which is not a factor, but we'll use the same theorem. By the way, the moment I saw that the highest power is cube, I know that this has 3 factors totally, out of which one factor is given. I can even tell you how to find out the remaining 2 factors. Should I tell you right now, or keep it a secret for some more time? We'll do it in the next exercise. 11th sum, will assume x as 2, substitute it in the expression here. Since it is a factor, the remainder is 0. See, in the question they have mentioned for the second divisor, the remainder is 3. But for the first divisor, they didn't mention any remainder. Why? Because the moment they mentioned that it is a factor, by default, we should know that the remainder will be 0 for that one. So I solve this and I get a linear equation. So you know where this is heading. Okay, the second divisor, x minus 3. So we'll assume the value of x as 3, substitute it in the polynomial. But here the remainder is not 0, the remainder is 3 given in the question. Read the question again. Go ahead, do that. So I solve and I get another linear equation, simplified of course. And now you know how to solve 2 simultaneous equations. Get the value of a, substitute and get the value of b. Now the 13th sum. What number should be added to this expression so that the new polynomial, when divided by x minus 3, the remainder will be 8. So first of all, is x minus 3 a factor or not? It is not. Number should be added. Well, let the number added to be a or k or whatever you want it to be. So the new polynomial is this plus a. Now they said, if I divide this by x minus 3, I get the remainder as 8. Fair enough. So let's assume the value of x as 3, substitute it in the polynomial. By the way, the remainder is 8 given in the question, not 0. So I solve this. There is only one unknown variable a, and I get the value of a. That is a required number to be added, minus 46. So the required polynomial would have been 3x cubed minus 5x squared plus 6x minus 46. But they have not asked us to write it in the end, so it's fine if you don't write it. Now the 15th sum. The polynomials this and this. Okay, 2 polynomials. So let's call this as f of x and let's call this as g of x. We can use any letter actually, as long as it is not repeated. So don't use x and a, which is already used here. I like f and g. Function of x. They leave the same remainder when divided by x minus 2. Okay, so if I divide this by x minus 2, let's say I get a remainder called z, and if I divide this, I get the same remainder. And we have to find the value of a, which is the unknown variable here. It's not mentioned that this is a factor, by the way, so remainder won't be 0. I don't know what the remainder will be, but the remainders are going to be equal. That's all we know. So let's find the remainders of both of them and let's equalize them. Let's start with f of x, function of x. We substitute the value of x as 2. Whatever answer we get is the remainder, whose exact value we don't know because we don't know the value of a. Don't write here 0, it is not a factor. Same thing for g of x, another function of x. Again, substitute x value as 2 and get some answer. That is the remainder when you divide the second polynomial by x minus 2. So I got two remainders, this and this. But they mentioned that the remainders are equal. When you substitute x as 2, the remainders are equal. That's what they said. So we solve it and get the value of a as 10. 17th question is answered. Now, in exercise 8b, cancel question 1.1. Let's do question 1.3. But read the question carefully. They said using the factor theorem, show that. Don't forget to show that this is a factor of this. Second part, factorize the expression completely. So there are two parts of this sum. The first part we already know how to prove it as a factor. Substitute the value of x. If you get the answer as 0, that means it's a factor. What's the value of x you will take in this sum? Think about it. Pause the video and think about it. Okay, ready? We'll assume the value of x as minus 2 upon 3. Did you realize how? Well, I shifted 2 here, it became minus 2, then 3 came down, minus 2 upon 3. So if I substitute this in the polynomial, don't assume it to be 0. We have to show that it is a factor. It's not given that it is a factor. So just calculate and get the answer. And the answer is indeed 0. This proves that it is a factor. But the next part says, factorize it completely. See, the moment I saw this polynomial, and I saw the highest power is 3, I knew that this has 3 factors. Out of which one factor we have just proved, but I need to find 2 more factors. So that's where now we have to do the division method. We can do the trial and error method also, but that is so time consuming and it's not allowed. So we'll just divide it. How to do the division? Well, this is the dividend and this is the divisor. Be careful that the powers are in descending order. That is the highest power, 3, 2, 1. It is not mentioned, but we know it's 1. And here the power is 0, by the way. X raised to 0, anything raised to 0 is 1. So it's not written. But actually the power is 0 out here. And even here it should be in descending order. Yeah, x raised to 1 and there is no x out here. This is very crucial. Otherwise we'll get confused if you don't take care of this. Usually you will not get it jumbled up. But what if it is? Also, what if there is something missing? What if they give you 3x cube minus 3x directly? So the power of 2 is missing. So when you write it, make sure you mention the power of 2 also, which would be something like 3x cube plus 0x squared minus 3x. Notice how now I have power of 3, power of 2 and power of 1 all in order. And because I wrote 0 as a coefficient here, this term doesn't actually exist. So I get back my original question. But making sure that everything is in place, 3, 2, 1, we won't do any silly mistake. It's unlikely you'll get such complicated sums, and there are no such sums in your exercise. But you need to be aware of all these things, at least for the higher standards. But the question still remains, how do I divide it? Well, focus on the first term, okay? Just the first term. First term here and the first term here. Don't forget about everything else for a moment. Divide this in the rough work or mentally. 3x cube upon 3x. So 3 and 3 cut, x squared. Answer is x squared. Plus or minus? I don't see any minus sign, so plus. So that is the quotient out here, x squared. You know why? Because now 3x into x squared is 3x cube. So that goes away. Cut. Subtraction. We're doing subtraction here. But what about the other term? that is also involved, right? It's a binomial, by the way, not a monomial. So here, again, you'll have to multiply this 2 with x squared. The first term gets the freedom to choose the quotient, not the second term. So 2 into x squared is 2x squared. Write it below the power of 2. Powers should match. It's incidental that both are same and they got cut on subtraction, which is not compulsory everywhere. Carry forward the other terms. So that's the end of step number 1. Step number 2, repeat step number 1. Focus on the first term and the first term. Minus 3x upon 3x is minus 1. So write minus 1 in the quotient, because 3x into minus 1 is indeed minus 3x. Signs have to be same so that when I subtract them, minus becomes plus and this gets cancelled. That's what we wanted. We want the remainder as 0. But what about the second term? Well, let's see. 2 into minus 1 is minus 2. Great. Even that gets cancelled and I get the remainder as 0. So that means this is the quotient. So I am able to factorize this into this, into this. If you literally multiply this, I bet you'll get the same answer. But I said that when the power is 3, there should be 3 factors, that is 3 brackets, 3 pairs of brackets. Yeah, because x square minus 1 can be factorized further, right? It's x plus 1 into x minus 1. So see, you've got 3 pairs of brackets, 3 factors. So when they say factorize completely, they want these factors written like that. Next, in question 2, cancel Roman number 1 and Roman number 2 and Roman number 5, and let's do Roman number 4. Using the remainder theorem, factorize each of the following completely. They have not even given us one factor. So how do we start? We'll have to do the trial and error method, but I'll tell you a trick. Look at the last constant. What are the factors of 63? 1, obviously 1 is always there. 1 and minus 1 both. 2, no, 2 won't go. 3, yes, 3 works. So always try with 1, minus 1, 2, minus 2, 3 and minus 3. Substitute one of these values in this expression. Check. Are you getting the remainder as 0? The answer is 0. If you are, that is a factor. So 2 is ruled out here. 1 is also not working. You can try it. And it's working with 3. You have to literally try it in the rough work column first. Then only you can start solving. 3 and minus 3, try both. See here. If I assume x as 3, if I substitute 3 everywhere, I am getting the answer as 0, proving that x minus 3 is a factor. How x minus 3? You know, if x is equal to 3, 3 goes to the left hand side, becomes x minus 3. The signs always change, correct? So it is a factor because the remainder is 0. But how did I know that 3 will work? I didn't. I tried it in the rough work. 1 minus 1 didn't work. 2 won't work at all because 63 doesn't go by 2. Minus 3 won't go, so 3 goes. Actually, minus 3 was also giving me a 0. So I could have assumed x is equal to minus 3. And then if I would have got it as 0, I would have said that x plus 3 is a factor. That's okay. Our aim was to find any one of the 3 factors and I got one factor. Good job. And now you know how to divide further. So that's your polynomial. Arrange in correct order? Yes. Look at the first term divided by the first term. 4x cube upon x. X cut x squared. 4x squared. So right here 4x squared. So that's why we get x into 4x squared is obviously 4x cube. So that's gone. That's what we always want. We want it to go away. Second one has no choice. Minus 3 into 4x squared is minus 12x squared. We are subtracting, remember. So 7x squared minus minus becomes plus, by the way. Don't forget to change the signs. So that becomes 19x squared here. Carry forward both of them. That's the end of step 1. Now step 2, repeat step 1. Focus on the first term here and the first term here. 19x squared divided by x is plus 19x. Signs matter, okay? If there was a minus sign here, then it should have been minus 19x. So 19x. Yeah, x into 19x is 19x squared, so that goes away. And minus 3 into 19x. Minus 3 into 19x is minus 57x. Now we are subtracting, so the signs will change and I get 21x and carry forward this. So again, third step, divide the first term with the first term. 21x upon x is plus 21, so write plus 21 in the quotient. So I get x into 21 is 21x, so this gets cancelled, 0. Good news, minus 3 into 21 is also minus 63. Even that gets cancelled, I get 0. So this is the other factor. But hold on, if I'm saying that this is factorized into 2 factors, but I told you I need 3 factors, so how do I get the third factor? Well, by splitting the middle term. You know, we've done this in quadratic equations, remember? We split it in such a way, 12 and 7, such that their product is equal to the product of the coefficients of the first and the last term. So 4 into 21 is 84. And 12 into 7 is also 84. Signs also check out. So that's splitting the middle term. Now take out common. Here what is common? 4x is common. Great. This is left behind. Here what is common? 7 is common. If nothing was common, we would remove 1 as common. Take care of the signs. No negative signs here, so it's easy. These two brackets have to be the exactly same brackets, obviously, so that now I can write this as one factor. The remaining 4x plus 7 is dumped in another pair of brackets, and that's how I got my 3 factors. Notice that this I knew was a factor by trial and error method, but if you would have started off with this as a trial and error method factor, you would have got these two as the final answer. Ultimately, these 3 are the factors. That's it. No other factor will pop up. Now the fourth sum. Factorize this expression and find all possible values of x. So this is same as the previous sum. We'll have to use a trial and error method. 18. Well, 1. Try 1. Try minus 1. Not working. Try it and tell me. 2. Try 2. Try minus 2. Try 3. Try minus 3. I think 2 and 3 will work. Anyway, I just wanted one of them to work. Okay, x is equal to 2 is working. What do you mean by that? I mean that if you substitute x is equal to 2 in the polynomial, I get the answer as 0. So when the remainder is 0, I say x minus 2 is a factor. And once I get one factor, I can get the remaining 2 factors by the division method. You all know how to do division, right? First term upon first term and so on. So don't copy this, try it on your own now. Come on, pause the video, solve it, and the biggest challenge here is taking care of the signs. Don't forget that we are doing subtraction here, so the signs will change. So it's minus 3x and there is a plus sign here, so it will become minus. So minus 3x minus 6x is minus 9x and so on. And the remainder has to be 0, absolutely has to be. So now I got 2 factors, but I want 3, so I will do splitting the middle term. So again, try the splitting on your own. Come on, 2 into 9. 2 into minus 9 is minus 18. Minus 18. And minus 3, I want to split it into 2 numbers such that their products is minus 18. I'm getting minus 6 and plus 3, which gives me minus 18. So you should try all the pairs, you know, minus 18 into 1, 9 into 2, 6 into 3. Yeah, these are the pairs. You should try. Their products are giving me 18 and the addition should give me 3. Addition or subtraction should give me 3. Will this work? Nope. Will this work? No. This will work. Their subtraction gives me 3. By the way, I want minus 3. So please give the minus sign to the bigger number 6 and the plus sign to the smaller number 3 so that their addition is minus 3. And now take out common. Here what is common? 2x is common. Here what is common? 3 is common. Notice how the brackets are same. So that is the second factor and I got the third factor. But they have also asked find the values of x. So x is equal to 2, x is equal to 3, and x is equal to minus 3 upon 2. That's the solution set. How? Well, if you assume it to be equal to 0, 3 shifts and becomes minus 3 and 2 goes down. You know, the usual thing. The 3 factors. If you would have assumed, started off with x is equal to 3, you would have got the remaining 2 as the answer, definitely. Now the 6th question. The expression, this, leaves remainders 0 and 30 when divided by this and this respectively. Remainder 0, that means x plus 1 is a factor. Remainder 30, that means 2x minus 3 is not a factor. So I guess I'll have simultaneous equations to get the values of a and b, b and c. And they've asked us to factorize completely, so they want the third factor, the second and third factor as well. Seems to be a long sum, but the concept remains the same. First, let's start with x is equal to minus 1. I know it's a factor. I know the remainder is 0, so I can write it and I'll get one equation here. Next divisor is this. Substitute x is equal to 3 upon 2. It is not a factor. Don't write remainder is 0. In fact, they've said that the remainder is 30. So after substituting x as 3 upon 2 everywhere and the remainder is 30 and the unknown variables are b and c, solve it, do the LCM, do the fractions, multiplication, addition, subtraction, and get the other linear equation. So I got two equations. So now what? Well, simultaneous equations by any method. I'm going to multiply the equation number 1 by 4 so that the 4c and 4c get cancelled and I'm left with b. I'll find the value of b, substitute it in the previous equation and get the value of c. Now, since we have the value of b and c, replace b and c with these numbers and get the proper polynomial. So now we know what is the actual polynomial. And they said factorize it completely. Do we have at least one factor for it? Yes, we do. We already have one factor, which is x plus 1. That's nice. So now I can divide it by x plus 1, long division. Of course, remainder will be 0. And I can get the second factor. But I need 3 factors totally, right? So I got one factor. And this can be solved by splitting the middle term to get the remaining 2 factors. So that's how I got all 3 factors as required. Next, in question 8, 9, 10 can be cancelled. In exercise 8c, cancel all the sums except 4, 9, 10 and 11. And out of that, we are doing 9 and 11 right now. So question 9. There is a polynomial which is completely divisible by x square minus 1. Oh great, factor is given. That means remainder will be 0. Find the values of p and q. Hold on. If I want to find two values, p and q, that means I need two equations so that I can solve it simultaneously. So they should have given me two factors, or at least one factor and another divisor with a remainder. But they've given me only one factor. No, look carefully. Actually, they've given you two factors. If this is divisible by x square minus 1, and x square minus 1 is nothing but x plus 1 and x minus 1, that means they've literally given you two factors for this polynomial. So now you know how to solve this. First, we'll assume x as minus 1, remainder is 0, and get an simultaneous equation, first equation. Then we'll assume x as 1, substitute remainder is 0, because even this is a factor, and you'll get the second linear equation. Solve them simultaneously and get the values of p and q. But the sum isn't over yet. They said factorize it further. That means they want us to find the third factor also. That's really huge sum, but it's easy. First of all, substitute the values of p and q to get a proper polynomial. And now, you can either divide it by x plus 1 or x minus 1, but I am going to divide it by x squared minus 1. So that directly I will get the third factor that I don't want to do splitting the middle term later. So something different here. When I do first term divided by first term, 3, let me just write it down, 3x cube upon x squared, cut, 3x is left, plus sign, yeah, plus sign, so 3x, so this is gone, fine. But then minus 1 into 3x is minus 3x. I can't write it below this because this is x squared. I will write it below this. See, the powers, like powers should be below each other. So minus 3x sign will change, of course, and this will go away. Good news. Bring down the remaining 2. Alright, again, first term upon first term. That's plus 4. So plus 4 in the quotient. This goes away. Minus 1 into 4 is minus 4. So this goes away. Remainder is 0. I got my third factor. So finally, I have been able to factorize it completely. And now the last sum, 11 sum. When this is divided by this, I get remainder A. Okay. And if this is divided by that, I get remainder B. Fine. And they have mentioned 2a plus b is equal to 0, and find the value of small a, which is a missing variable out here and out here. So no factors are given here. No remainders will be 0. That's okay. We'll use the same theorem. First of all, we have function x and function g. Two separate functions, solve them simultaneously. Here it was divided by x minus 1, so if I substitute x is equal to 1, I will get a remainder which is already given in the question as a. It's not 0 by the way, it's not a factor. So I get one equation, a. Okay. Similarly, if I substitute x is equal to minus 2 out here, I should get the remainder as b, given in the question. So I get this equation. So I got capital A value and capital B value. Now, they have mentioned that 2a plus b is equal to 0. So if I substitute a as minus 5 minus 4 from here, and I substitute capital B as 32 plus 4a from here, yeah, you should write from equation 1 and 2 and all that. It is equal to 0. Now in this equation there is only one unknown variable, which is small a. Open the brackets, use a BODMAS rule, get the value of a, and sum is over. Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.